Algebra students. Today we're doing 6-2 exponential functions continued. You can put your name, date, and period at the top. Today's learning target is students will write exponential functions using tables and graphs. The vocabulary for today is asymptote, asintota, constant ratio, relación constante, exponential function, función exponencial. For example 3, we are writing exponential functions. Part A, what is the written form of the function represented by the table? So the function rule for exponents or exponential functions is f of x equals a dot b to the x, where a is the initial amount and b is the constant ratio. So that's something that you're going to be using today, the exponential function rule. All right, so first we need to know what the initial amount is. This, where x is 0, f of x is 4. So the initial amount is 4. And then the constant ratio we find by figuring out how we get from one f of x to the next f of x. And so to figure this out, if we did 12 divided by 4, we get 3. If we do 36 divided by 12, we get 3. 108 divided by 36, and 324 divided by 108. All of these equal 3, so that is our constant ratio. Then we need to plug that into the function rule. So f of x is equal to the initial amount times the constant ratio, which is 3, to the power of x. All right, so just a reminder, this function rule is what we're going to be using when we write a function. Part B, what is the written form of the function represented by the graph? So again, we need the initial amount, and the initial amount is when x is 0. So x is 0 here. F of x is 128. So the initial amount is 128. Then we need to find the constant ratio. So how do we get from 128 to 64? How do we get from 64 to 32? How do we get from 32 to 16? How do we get from 16 to 8? And how do we get from 8 to 4? Well, now we're dividing by 2. But to show dividing by 2, we can also multiply by 1/2. So 64 divided by 128, 32 divided by 64, 16 divided by 32, 8 divided by 16, and 4 divided by 8. All of these are equal to 1/2, which is our constant ratio. So now that we have that, which is finding it from a graph, we plug it into our function. F of x is equal to the initial amount times the constant ratio 1/2 raised to the x power. And x just means we can plug in values to x to figure out what the function or the f of x would equal. Let's do the first try it together since this is not quite a table or a graph, it's a set of points. The initial value is this, 0, 3. Initial amount is 3, and the constant ratio if we go backwards, 768 divided by 192, 192 divided by 48, 48 divided by 12, I know is 4, and 12 divided by 3 is 4, so the constant ratio is 4. The function is f of x equals the initial amount times the constant ratio raised to the x power. We'll pause the video and you can complete the try it part 3b on your own or in your groups. And when you're ready, we'll turn the page. On the back of your notes, you have an additional practice and I want to help you get started on it. So we're going to draw a coordinate plane with our x and y axes. And then you're also going to want to make a table to be able to graph these values. So you'll have x and f of x. And you can use the values of -1, 0, 1, and 2 and plug those in to your function. So where the x is, you'll do 3 to the -1, and in your calculator, you can use a graphing calculator, it would be like 3. You would use the button that looks like this. It's a caret, meaning raise the roof. And then you'll want to use the button that looks like this. It's a positive, negative, and I think it's next to the 0 on your calculator. So you can put a -1. And that'll show you what f of x is at when x is -1. And then you can plot those points. For the next function, you're going to use the same axes, and you're going to each square be equal to 1. And so you'll have f of x, you'll have x and f of x in your table. And you'll want to use some negative values. So you could do -1, 0, and 1, and that should give you an idea of what the graph will look like. Okay, and for the next one, you're going to have a different scale. So go ahead and draw the x and y axes like this. And the x's you'll count by 1s. But the y's you will want to count by 2s, just so it fits. And in your table of values, you can use x, f of x, and you could use 0, 1, and 2. That should give you enough values to see what this will look like, maybe a 3. And you'll plug these into the calculator like this. 8 times, and when it's to the 0 power, it's just 1. So 8 times 1, that's 8. So this first value is going to be 8. And the next value is just going to be 8 times 1.2. But when you get to the squared, you can use this button on the calculator and you can put in 2 and see what that equals. If it doesn't match the pattern, you may need to put this piece into parentheses. Okay, we'll pause the video and you can watch the rest of the video on your own to help you through the other problems. Okay. Write an equation for each exponential function. So for this function, we have this initial value here, and then we're going up. It's increasing. So these are the points that are important. When x is 0, when x is 1, when x is 2, and when x is 3. So the initial value right here, if you look closely, it looks like we're counting by sixes, but this is in the middle. So that looks like 0, 3. And the next value is 6, so 1, 6. The next value is 2, 12. And the next value up here is 3, 24. You don't have to draw these arrows, I'm just showing you where these points came from. And then you have an initial amount and you can figure out what the f of x equals for the initial amount times the rate of change to the x. And similar on the other problems, you have a table that you can figure that out from. This looks like 5. This one's a little tricky. So maybe we don't use those points and we just use those 2 points to figure out what the difference is, because it looks like we're dividing to get from 9 to 5. So it'll be a fraction, 9 divided by 5, 9/5. Looks like what the rate of change is for that. And then number 7, explaining the key features, including the asymptote key points on the graph, domain, and range. Okay. Well, the asymptote for this function is that as x increases, the y is approaching 0. So it's approaching the x-axis. So the asymptote is the function curve approaches the x-axis. And then the key points on the graph would be, so A would be the initial amount, which is always 0, comma, and then it would be at A, wherever A is at. Another key feature would be that at the point 1 for x, it would be A times B. So that would be a point on the graph. The domain is all x, the x values would be all real numbers. For x. And the range would be all positive values for y, so all y's that are greater than 0. And it can't actually equal 0 either. Y will never equal 0 because of the asymptote. And I think you guys can figure out number 8 based on our notes from yesterday.